Find the volume of a solid formed by rotating the region under y equals f of x equals x to the negative 1/2 over the interval 1, 4 about the line x equals negative 3. The first thing we need to do is to sketch the bounded region. We were given the curve y equals x to the negative 1/2, which is simply y equals 1 over the square root of x. The region is under this curve and over the interval 1, 4. This is the interval 1 to 4. So the bounded region is this enclosed region. This time we take this region and we rotate it about the line x equals negative 3, which is not neither the x nor the y axis. Using the shell method, we will slide the solid parallel to the axis of rotation, which is a vertical line. The thickness is therefore delta x because the cross-section is now parallel to the vertical line so that it is perpendicular to the x-axis. We obtain a representative shell whose radius is a horizontal line. The radius is always from the axis of rotation to the point where we slice the solids. We would label this point x, y. To find the radius, we would need to find the distance, the horizontal distance from the axis of rotation to that particular point. This is the horizontal line, and so we would take the x on the right hand side minus the x value on the left hand side. This will give us the radius of the shell. This horizontal line segment ranges from x equals negative 3 to x. And so the distance of this horizontal line, which is the radius, is x minus negative 3. X on the right minus x on the left. Simplifying this, we have x plus 3. The height is the value of the function, which is simply y in this case. Since the thickness is delta x, we would need to express the radius in terms of x, which it is already in terms of x. We also need to express the height in terms of x as well. The function given is y equals 1 over the square root of x, so the height is simply 1 over the square root of x because the height is y. It is the vertical distance. The volume of a representative shell is always 2 pi r times the height times the thickness, but the thickness is delta x in this case. So this is 2 pi xi plus 3. This is the radius of the shell times the height, which is 1 over the square root of xi times the thickness delta x. The total volume of the solids is the sum of these vi as I go from 1 to n. This is 2 pi times xi plus 3 over the square root of xi times delta x. And as n goes to infinity, we obtain the definite integral 2 pi x plus 3 over the square root of x dx. To obtain the upper and the lower limits of integration, we observe that we only slice the solids from x equals 1 to x equals 4. So the lower limit of integration is 1 and the upper limit of the integration is 4. 2 pi is a constant, so we can bring it to the front of the integral. We need to evaluate 2 pi, the integral from 1 to 4 of x plus 3 over the square root of x dx. To evaluate this by hand, we need to simplify the integrand first. This is x over the square root of x plus 3 over the square root of x dx, which is 2 pi, the integral from 1 to 4. X over the square root of x is x to the 1/2. 3 over the square root of x is 3x to the negative 1/2. We can now easily evaluate this to obtain the antiderivative so that we can use the fundamental theorem of calculus. And if we were to work this out, we will obtain 64 pi over 3 as the exact volume of the solid generated by this region rotated about the line x equals -3.